Alright, so here we go. I initially planned on doing some gadget stuff, and we're still going to cover it a little bit. But what we're looking at now is an old, tired War FTPD exploit. The Metasploit framework already has it working on XP Service Pack 3, but we're going to turn it back into a structured exception handler crash instead of so that we can cover structured exception handlers instead of using the newer gadget type of an approach. So, and we'll be able to cover what a gadget type approach is as well. And what we have is the old tired exploit. We've already covered MSF payload, MSF encode, and the pattern create and pattern offset stuff. So what we're going to look at now is task list memdump, MSF PE scan, assembling the opcodes so that we know what text to regex for on MSF PE scan. Byakugan, which is a great WinDebug plugin. Thanks HD, we really appreciate it. And it is awesome. Then we've got, and we don't even begin to cover what Byakugan's capable of in this video. All we're going to cover is searching for opcodes with the Jutsu component of Byakugan. The structured exception handler plugin for the safe structured exception handler plugin for Ollie, and the method for doing structured exception handler crash exploitation. And so here we go. I use Ruby because it is what the Metasploit framework is written in, and it's Python's a scripting language, so is Ruby, and it's kind of a holy war on which one is better. So we're not going to say that one is better than the other because they can both do really incredible things. But we're going to require the net FTP library. Then we're also going to require socket just in case, because I goofed around with a couple different ways of doing this. We've got the host that we're going to exploit. We set it in a variable, so if I wanted to launch this and parse our environment variables, I could, and shovel that into the host area. Username is what we're exploiting. We could also exploit the password field. Anyway, so we're making sure first that the netftp library works as it should. That's what those lines are. We sleep for 5 seconds. It gives us a chance to see that it worked. Then we come down to making it fail. We got a bunch of string declarations. I've had some weirdness previously with UTF not converting properly to Unicode or something. So I declare all my junk first. Sometimes it helps. Then we start building our buffer. Either way, we're going to need our leading garbage. We would have found this with our pattern create and pattern offset variables to get us up to EIP. Then Metasploit uses the push ESP return gadget, and the gadgets are really assembly that operates on memory in a way that we want it to, and we're not writing all of this assembly, so there could be a huge assembly structure that does really complicated things but results in the outcome that we want. This is a pretty simple one. It's 2 instructions, push ESP return, and it's what the Metasploit framework uses. Then we're going to, okay, that's what we would need if we had a structured exception handler crash. Now we've got our NOP sled that leads to our shellcode. And we generated our shellcode as we talked about before. Now we stuff all that into a buffer, and we create our new FTP connection and push our buffer at it. And it should complain that either the session is disconnected or it requires a password. Either way, we need to catch the error and tell the user that we should have a port open. So we're going to now launch this particular exploit. we come over to our Windows box. It's not activated yet. Yeah, I just installed it. And FTPD is running. And yeah, so we can come back here and launch our exploit. This is not an SEH exploit. I just named it that because of the work I was doing on the other end of the tutorial. And we should be able now to connect to, and we can. Yep. And we exit. And that should clear that. And we come back here and yep, FTPD crashed and our listener is no longer there. I'm just going to let that do its thing up here. So we can now restart our FTPD, and we're going to need to take a look at a couple things in Ollie to continue with the tutorial. I launch it and then attach instead of launch it within Ollie because some applications just make you cry at the beginning of the application. So I give it a couple seconds to run and then attach to it because it just complains badly. Now we've got it running and it should be fine. We come back and take a look at, let's see. Alright, so we did that part. We need to look at task list, memdump, and MSFP scan. I probably shouldn't have connected Ollie, but well, yeah, maybe. Alright, we'll go look at it here in a second. What we're going to be doing is saying, first we need to be able to search, and to make the demo quicker, I already dumped with, I already dumped with memscan, so we've got system console here. Yeah, you can see we don't have a 4444 port open there. Anyway, so we've got okay, yeah, that's me being a Linux dork. We've got the 552 directory. The 552 directory was created by tools, memdump, tools, Alright, we've got memdump there. So what we do is say task list, and it gives us the PIDs of all the process IDs of all the executables that are running on the system, and we know that it would be 1396 in this case, so we would say tools memdump. Oh, that's what's doing it. I'm putting my slashes in the Linux direction. Tools, memdump, and if you just launch it, it's going to complain that it needs a process ID and a dump directory. If you just feed it the process ID like that, it'll create the directory 1396 and put all the dumps in there. So that's how memdump works. Then we do. It would take some time to dump the memory. So we're just gonna skip that part because I already have it done. I've had limited success with using the pop-pop-ret search from MSFP scan, but P is a search for pop-pop return in 522, and we could tell it any directory we wanted. Ruby 552, and these are all the different memory sections that are available. and we wanted it to search through 71A, I think it's 71AB, and we weren't looking for a pop red. We were looking for a, what were we looking for? That's a good question. We were looking for a push ESP return. So that brings us to our little piece of Ruby code here. Push ESP return, and it assembles it for us and tells us that it's opcode 54C3. This is really a very simple piece of Ruby code. It doesn't do much of anything at all. RunMe just pulls in a class, and the class is opcode, opcode define, and it's really just a string followed by a string that's going to get replaced, followed by another string, and then it calls some system commands to assemble it, link it, and then dump it. So that's really very simple, but it's an example of what we might want to do. And I was going to include it in the Ruby for Hackers segment, but I used it for this, so I figured I'd show it here. Oh, I forgot what the opcodes we were searching for are. We were searching for 54C3. And we're searching through this memory area because the exploit told us it was there. We'd be searching through a different area if we were trying to find it. And what we're doing with the safe SEH thing, because that's where we're going soon, is alright, so when we're using gadgets, we have more options available to us, but when we're using structured exception handler crash, we have less options. That means we can't use safe SEHs on, we can't use no SEH, we have to use safe SEHs off. It leaves us very little in the way of options. We've only got these two. This one has a leading null, so that's going to take it right out unless we do some really complicated stuff. And I'm not even sure that it's possible in this particular instance. But we do have this one that we can search through. That's 5F, 4FF, whatever. And the bonus there is that it's included with the installer, so if there's a Windows update, because this is included in our application directory, and it's an older application, its search path will probably be the local directory first. So we need to find a, to do structured exception handler crashes, we need to find a pop return in here, this particular library. Alright, so it did find it, and it found it at that address, and that address is what we used in our exploit. Just proof that all the different little pieces of code that we've been goofing around with work. Alright, so let's turn this into a, yep, that's the address. So we're going to now turn this into a structured exception handler crash. And we'll come back through and explain it momentarily. Alright, so that should now work, and Alright, so now what we're going to do, we can go ahead and turn this off too. We created our strings, we created our leading junk, because we're going to need it either way. We overwrite EIP with something that's going to go to an inaccessible memory location. It can be anything that will make the application crash. Then we've got our NOPs up to the structured exception handler, and we've got our to the pointer to the next structured exception handler in the chain, and then we've got our short jump, so that we go here instead of the next handler. And then we've got our structured exception handler overwrite, that's a pop return. basically what happens is it goes, hey, you're going to go. Ooh, I need to comment that out. It basically what it says is you're going to go here next. It means you're going to go 6 bytes further in memory if this structure exception handler returns OK. And then what this is going to do is say pop return and rearrange the stack so that the structured exception handler is gone. And then the Metasploit framework is just doing its thing. Alright, the knob sled is going to be shorter now because we don't have to overwrite this stuff. And we've got our shellcode. And then we build our buffer with all the components that we laid out earlier. And we should have an open port. Alright, so the exactness of exactly what goes on in here, essentially what you need to know is there's a short jump on the next in chain, and then there's a pop return in place of the second part, and you would have found that offset information by using pattern create and pattern offset, looking for. Is this running? Yeah, this is running. Okay, well, alright, let's just restart it. Restart, yes, and what I was talking about with the complaining on startup is that it generates a couple of exceptions and you have to get past the pauses, and that's why I normally attach to it instead of launch it. Anyway, so what we'd be looking at is, alright, that's running, and we launch our exploit. And we would just do this with our huge string of A's that would overwrite EIP initially. And Alright, and it thinks we should have something here. EIP is overwritten by 41414141. And when we look in the stack here, this is EIP. And we can now look at our where our next SEH record is going to be, and our structured exception handler is going to be, and we can use pattern create, pattern offset, or we can use the numbering here to say it's going to be 8 plus this in hex. Anyway. So, yeah, let's go ahead and change that back to absolute. And it's less confusing if you just use pattern create and pattern offset, but you can do it either way. Alright, that about does it for that. It won't let us pass that exception properly, I don't think. Let's see. Let's try it. On-screen keyboard, Shift 7. Yeah, it won't let us do it. Anyway, so we have to kill it and start it back up again. Started back up. We launch our exploit. And so we know that I'm not just talking a bunch of junk. We connect. Give me a second. Let's see. Yep. Okay. I guess I didn't give it long enough. There it is. Alright. That's me being silly. I forgot my port numbers on at least one of the telnet, 2 of the telnet commands. I forgot my port number, so I wasn't talking junk. And then when the exploit failed to launch that last time, I figured it was because the FTPD client was already frozen. Anyway, so now we covered how to use MSF PE scan and the Ollie plugin. So that works. Now we can do something else which is interesting, and I find it more useful searching for pop-pop returns this way. To do a Windbug attach, and okay, and there's way more that this plugin can do, and there's way more that you can do in Windbug, but load the octagon. It's loaded, and then we do a Jitsu opcode search. It's search opcode, and that's capitalized. Pop return. As we covered before, you're going to need to fail to assemble instruction pop ret. There we go. Now it's run through all the junk, and it's going to find some that we can't use, and initially it's going to list a bunch that are just pops, but it'll cycle through it again and it'll be pop, then it'll cycle through it again and it'll be pop return. So we just need to let it do its thing, and that'll take some time, but this is why I did this part last. And my screen will probably turn gray there for a while. Anyway, but the outcome will ultimately be that it will give us a bunch of addresses, one of which will be this one. And we knew that it needed to be in that 5F leading library because of the safe SEH Ollie debug plugin. And I think that about covers all of it. Let's see. Yes, it's null tired exploit. Yes, MSF payload, MSF encode, pattern create, pattern offset, task list, mem dump, MSF BE scan, assembling, Byakugan, the most basic component of it, Jitsu, SSCH, and how we actually exploit safe SEH. Alright, I think that about does it, and thank you for listening. You're welcome to comment.